Well, welcome back to the final test review, test number 3. Remember, test number 3 is going to be coming up very shortly. This review will give you some additional practice in problems that may appear, or the types of problems that may appear on your test. Some general information. Our test number 3 is Wednesday, April 22nd, 2020 at 1 p.m. or 1300 hours, and it will be via the My Econ Lab. You must write the test at this time. There are no changes allowed. Ensure that you have a valid My Econ access code. Multiple temporary access codes are not permitted and will be shut down. Many people had access codes, multiple access codes last time around that caused all sorts of havoc. So submit all your assignments 1 through 5 by Saturday, April the 18th, 2020 before midnight. Assignment 5 is your choice. One of the following: theory of production, cost of production, the short run, cost of production, the long run, or perfect competition. Once again, make sure that you are studying chapters 9 and 10 and ensure that you are practicing in My Econ Lab. Again, the test is Wednesday, April the 22nd, 2020 at 1 p.m. via the Econ Lab. Now, during this review, it's going to be predominantly silence. I'm going to give you approximately a minute to read each slide and then to make your selection. Some of them will require you to do calculations. Please have a paper and pencil at hand and your calculator so that you can answer the following questions. The review will be in 2 parts. This is part number 1. And once again, good luck in your test that's coming up. And hopefully we will see all of you come September. So one of the first things that you have to do is to be able to calculate your total cost. So for 12 dozens, it would be 12 times 6 is equal to 72, and the next one would be 13 times 7, which is 91. Your marginal cost is equal to the change in your total cost divided by the change in quantity. Elaborate those, substitute in the numbers, and you will get that your marginal cost is 19. Question number 2. Question number 3. So here you'll have to use the formula: the marginal product of labor is the change in total product divided by the change of labor. You'll have to expand that, plug in the details that you were given. And if we go back to the table, we'll see at the 4 employees, the output of Dutch apple pie was 40 units. At 3 employees, the output is 32. We plug those numbers into our formula and we get that the marginal product of labor is 8. Question number 4. So your average variable cost here is equal to your total variable cost divided by quantity. Your average cost can also be the average variable cost plus your average fixed cost. Needs four workers for 40 pies. Therefore, we will multiply the employees by the average variable cost and we get our total variable cost, which would be $200. Divide that by 40 units since we are producing it, and then we get an average variable cost of $5. The second part is our average fixed cost is equal to 200, our total fixed cost is equal to 200. Our average fixed cost is equal to also to 200. So our total cost is the addition of those two, which would be 400. Then we will divide our total cost by quantity, and our quantity is 40, our total cost is 400, therefore our average cost is 10. Question number 6. In the diagram to the left, which graphs a perfectly competitive firm's total profit curve, the firm is maximizing its losses at point or points. Our answer here is A. Question 7. This is the first way of doing it. Remember that marginal revenue is also equal to price, so you can also do it this way. Always remember that price is equal to marginal revenue is equal to average revenue, and that is where your demand curve is located. In a perfect competition, your demand curve is horizontal, parallel to the x-axis. For this problem, there are two steps that you must do. Here's the first one and the second one. Substitute the 28 into the equation that was given. You solve for Q. You were told that there are 300 suppliers. You will multiply the 300 by 3, and the total supply would be 900 units. Whoops. Sorry about that. So here's the model. We will superimpose our demand curve. As we mentioned a couple of problems ago, the demand curve for a perfectly competitive firm is parallel to the x-axis, the quantity axis, and the demand curve is located at the price, which is equal to marginal revenue, which is equal to the average revenue of the company. So the slope is 0. I'm going to keep this problem here. It'll take a couple of minutes for you to figure this out. Okay, here we will go. One of the things that we will do is we will have to use the relative economic efficiency ratio here, and that is the EER is equal to the value of the output divided by the cost of inputs. So we will have to multiply the output by whatever the sales price is, do the addition and multiplication and addition to find the cost of the input. So the value of the input is the amount of capital, the amount of labor that will be used in the first method of production, and it will be $86. The value of the output are the 24 watches times the $10 that they will receive for each watch for a value of $240. Now we will divide the 240 by the cost of the input, which is 86. And for every dollar that method one, for every dollar that you invest in method one, it will return $2.79. For method number two, we will use the exact same relative economic efficiency ratio. Calculate the value of the input once again, the cost of labor and the cost of technology, and we get a cost of $87. We will multiply the output by how much you received for each watch, and we will get a value of $250. 250 divided by 87 will give you $2.87 return for every dollar that you put in. So method number two is the one that you should select because it returns more per dollar than method number one. I've included this problem here because very few of you got it correct on the assignment number 5. The total cost of an organization is $120. Derive the average fixed cost curve geometrically and explain its shape. We did this for a number of problems in the theory of production where we drew a ray from the origin to a point on the curve, and we calculated the average product of labor, and then we took also the slope between 2 points, which gave us the marginal product of labor. Here we are asking just for the average fixed cost curve, which you will have to draw a ray from the origin to a point on the total fixed cost curve. The total fixed cost curve is a straight line parallel to the x-axis. So this is the algebraic equation. Average fixed cost is equal to your total fixed cost divided by quantity. We have our total fixed cost is 120. If we're doing it for 2 outputs, then our average fixed cost is 120 divided by 2, which is $60. This is equal to the slope of the ray from the origin 0 to point A. So the ray is 0A and is plotted at A prime on the curve, the average fixed cost curve that will come up shortly. When we have an output of 4, the average fixed cost is 120 divided by 4, which is 30. And this is equal to the slope of the ray 0b, which is plotted as point B prime on the average fixed cost curve. When the output is 6, our average fixed cost is 120 divided by 6, which is 20. And this is equal to the slope of the ray 0c and is plotted as point C prime on the average fixed cost curve. Other points on the average fixed cost curve could be obtained in a similar manner. So if you take a look at your top graph, we have our total fixed cost curve at $120. We will draw rays from the origin to the points on the curve. So remember when you do 2 graphs, 2-part graphs, the x-axis always has the same scale as the x-axis on both of them have the same scale. The scale on the y-axis, it doesn't really matter. So if you draw your ray from 0 to A, that would give us also the first point on the average fixed cost curve, and that would be at point A prime. Draw another ray from the origin to point B, take the slope, and that gives us our second point on the average fixed cost curve, point B prime. And do it for, connect those 2 points, draw another ray from the origin to point C, and we will get our third point, C prime, connect it, and then draw another ray from the origin to point D, and we will get our third point, D prime. And this is considered to be called the geometric way of constructing a curve by taking slopes of it. Remember that you drawing a curve, drawing a ray from the origin to a point on the curve gives us the average of whatever we're looking for. And if we're calculating the marginal change, then it's the slope between 2 points on the main curve. This is the end of the first review. Please continue to the part 2 for, um, for the last part of our review.